So Tweak Garrett is a 125-year-old mechanical contractor with approximately 800 employees. We're one of the largest contractors in the Midwest and very proud of our commitment to lean construction and innovation. We're moving forward under the following premise. You cannot optimize construction until you standardize it, and you cannot standardize it until you productize it. So that has been our focus, creating a database of constructible parts and pieces that contain contextual data that we can add seamlessly into the building model. Everyone's talking about maximizing prefabrication or off-site construction. Now the buzzword is modular. That's all great, but most of that happens outside the model. An engineer designs it one way, it's constructed or prefabricated by a contractor outside the model. The real disruption to our industry will be when a module or a product not only is standardized, but configurable, and then, lastly, with data attached to it, both digital and smart.
When we're starting off with a design build contract, our internal engineers will create the model and then begin to populate it with the design content. They'll add the ducts, the pipes, the VAV families. That will all be generated in-house and placed within the model at that time. Bid spec is the more traditional form of construction, and that is where an external consulting engineer will create a model and begin to populate it with content, usually the same kind of content, but they can put it in different ways and in different locations.
We are integrating estimating into the model. We're using what we're starting with, the idea of this streamlined approach of doing as much as we can with what we get. It just makes sense that we're not rebuilding it like we've talked about earlier, potentially. If the estimators can estimate inside the model, it makes sense. We're using those standard parts and pieces that we've determined and we know work in the estimate. So by having our standard library, we're able to use that standard library to estimate from. So with us building our own parts and pieces and constantly managing and updating them as they go, it allows us to use the same standard parts so pieces can be represented the same each and every time we use them. Us building our own allows us to know that we're using the correct content, and it allows for that seamless data flow.
For a consulting engineer, their product is that drawing package. So there may be information within the model that is not on the drawing package and therefore not verified by that consulting engineer. So we have to check each line of data, each parameter, and make sure that any information in the model matches the drawings for information that wasn't necessarily reported out on the drawings. A lot of times when you receive an outside model, there would be a disclaimer saying the data within this model is not verified. Please reference official documents. And that's the way it has to be done, because there has to be one source of truth. And right now there's no real set method for verifying data within a model or signing off on it.
So the information that can be integrated with a VAV within the BAS system in the model would be the end deliverable for the customer, having all information associated with that VAV digitally in the model for the life of the building, containing the design parameters, any kind of service requirement, and also maintenance.
The biggest hurdle to eliminating this rework generated by double checking or recreating is the fact that there is no standard location for that data. And because there's no standard location for that data, there's no standard checks and balances for that data. In the case of a VAV, one engineer might call it design airflow, another might call it cooling airflow, right? And if you don't know which of those two parameters to check or to verify, both of them have to be checked or verified, or both of them have to be created, or you have to go search through because maybe they called it total CFM. You just don't know. We need some form of standard location, and from that standard location, we can create a list of standard checks to verify a model. And until those things are established, we're going to have to double check everything. I would suggest the establishment of some industry standard for data within a model. There have been a couple of attempts, but neither of those have really addressed the location of data, the verification of data within a model. So that may be a consulting engineer working with a design build contractor to establish their own standard location and verification of data. Or it might be an industry standard. If it's not industry-wide, whenever you're working with a partner outside of that established standard, you'll have to verify their data, and that invites rework, that invites waste time in going out and double checking people's work. Because anytime an engineer is inputting data or making a decision, they're telling the model how much airflow is going through this VAV, and then another person has to go back and double check it. That's rework, right? Anytime they have to go out and reference an external document versus being able to reference that exact object within a model, that's wasted time. And so if we're really looking to eliminate as many aspects of waste as we can, we need a standard location. So this lack of ability to verify, certify data within a model or to trust the data within a model leads to rework in many cases. Specifically to the BIM workflow, it may be that prior to coordination, we have to double check the dimensional data within a Revit family or a BIM family. And it continues on past that, because there may be information in the model that we do trust, and that leads to further errors down the line in construction, and it could lead to rework in the field itself, not just within the office.
I think some prime examples of how we are making things better is using standard deliverables in every aspect, which has been a collaboration of families and parts that we're continuing to use across projects. Collaboration is helping on multiple different fronts depending on who we're having it with. Internally, collaboration helps amongst the team to get on the same page and everybody to be working together, and different ideas spark different solutions, which I think empowers everybody on the team to be better and make them want to do more. External collaboration that we're having between engineers, where we get a model that maybe some people are talking about starting over because it's not a good model or it's not the right results. the collaboration we're having with those engineers are they want to give us a good deliverable. They want to give us something that we can use. So we've had, in a few cases, good conversations with consulting engineers about drawing more like we want as a subcontractor or a trades partner. I think in this mindset, like we had previously discussed, of constantly wanting to improve, I think that makes all the troubleshooting easier when it's not just one person from the top or from the bottom trying to drive an initiative. The teams are seeing the benefits of working together and collaborating on issues, so that makes troubleshooting easier to come up with answers from multiple different people to get to a better solution.